33. So here we have an endgame play here. We want to reach 1 plus cosine squared x, which is pretty simple as it is. For 34, this is too simple to start on this side. This is the more complex things that you can kind of play around with to get to here. Like starting from here is too hard to get to here. Likewise, it's kind of easier to attack the side that has more stuff so that you can move things, where this guy doesn't have really too much to move. You don't know if you're going to reach something this strange. So you want to start with the side that has the more stuff. Okay, that's more complex. All right, so here we go. So put the equal sign. Now what we'll do here is we're going to go ahead and do the equal sign, and we're going to go 1 plus secant squared x, that is x, and then I do notice that 1 plus tangent squared, 1 plus tangent squared is actually secant squared. So I'm going to replace this guy with secant squared x. Now notice in my next step, I'm not going to write down this. He's my goal. Okay, I'm going to prove this. This is already known. Somebody already figured this out. We're going to prove it. And so what we do is we just make an equal sign to show that we're now going to do the next step. Now this is just like in problem 31 here and the one before that, where we split this guy, the denominator. We're going backwards from bringing in common denominators because that's the only thing we can do. Okay, so I'm going to go 1 over secant squared x plus secant squared x over secant squared x. Now what this produces is 1 over secant squared x plus 1. Excuse me. So these guys cancel out to 1, and then 1 plus secant squared x is actually cosine. And of course it's squared because secant is squared. And because these guys are in a specific order, it does help to do it like this. You can switch the order, obviously, because it's addition, but it is worth the extra step to make it look exactly as it is there, because it's a proof thing, okay? And so what we would then do is say, like, that's what I was trying to prove, okay? Mathematician will put a double bar there, and I think I might have said in another video, it's QED, okay? That was my goal. I've shown you what I need to show. All right. Over here, I'm going to start off with the most complex thing here and then shoot for that. Okay. So sine and cosine is fine. Now, what I'm going to do is I'm going to turn him into a sine and cosine thing. Okay. So equals sine and alpha 1 minus cosine alpha minus, and I'm going to switch him and make him a cosine alpha over sine alpha, because that's what cotangent is. Okay, he is cosine over sine. Now I'm ignoring this guy because that's my end game. As soon as I get to him, that means I'm done. I've got my proof. So I'm going to go equals, and what I'm going to do now is I'm going to combine like terms. I'm going to give this guy a sine and give this guy a 1 minus cosine alpha. Okay, so we're going to give them common denominators. Over here, we split them apart. Okay, they already had common denominators and we split them, but that served our purposes. For us, we're going to see where this takes us, because that's all I can see right now, is that if I gave him a sine, he'd become sine squared. And if I gave this a 1 minus cosine, I might be able to get a cosine squared going. And I know that sine squared and cosine squared together will give me an identity. That's pretty much what's got my gears going right now. Okay, so let's give this guy an extra sign. Okay, minus. Let's give this cosine a 1 minus cosine. Okay, all over. I like to put the single term in front, but it doesn't matter. It doesn't matter the order here. But now we've given this guy, you've done this before with rational expressions. Give this guy the sine theta, give this guy the 1 minus cosine, so that they can actually combine. Okay. Now what we're going to do is we're going to FOIL this, okay, and see what happens. We got a sine. Okay, and it's really important though that I say to see what happens, because this is a proof, and you just kind of like go where the algebra is taking you. There's really nothing else you can really say about it. Okay, you just kind of see where it takes you. And we do get a positive cosine, and it will be squared. And that would be over sine alpha 1 minus cosine alpha. Okay. All right, so bingo. I see it. There's our sine squared or cosine squared. That actually is 1. Okay. These guys combined, and I'm just going to take the time to rearrange this a little bit so you can kind of see what's going to happen here. It's really beautiful, actually. And just think, too, when you are doing these, you're dealing with ratios. You're dealing with O's over A's over H's and H's over A. Like, it's just, these are all just ratios that are just these incredible properties that kind of play out through the, I don't know, the elaborations of the universe. It's really incredible. These guys combine for 1. All right, something very elegant happens now, so that the 1 minus cosine cancel out. Very satisfying. So you're left with 1, and you just got a sine. Now that right there is good, but looks like our goal was just cosecant, so we're just right there in our next step. Okay, and the QED. That is what we were trying to prove. All right. All right, that is it. Like I said, the test is going to be significantly shorter than this. This was just trying to play out all the possibilities. And remember this one too, you can retake it if you are not satisfied with it. Trig is a fickle subject. Comes and goes. All right. So that'll be it.